The reciprocal function is defined to be f of x is equal to the reciprocal of x, or 1 over x. Now we can't have a 0 in the denominator, so we're going to have a vertical asymptote at x equals 0. As x becomes infinitely large, this is going to go to 0 very quickly. And as x becomes infinitely large in the negative sense, this will go to 0 as well. So we're going to have a horizontal asymptote of y equals 0. Now you can see you have quite a bit of symmetry. To graph these, you really only need 1 or 2 points, and I tend to like to pick 1. So if I were to graph x is 1 and negative 1, when x is 1, y is 1 over 1, or 1. That's a pretty easy point to graph. And it's going to go up infinitely and become very close to this vertical asymptote. And then it's going to come down and approach the horizontal asymptote. At negative 1, this is 1 over negative 1, or negative 1. Just gotta love symmetry, don't you? And you have the same sort of curve in quadrant 3. Now, if we want to transform it, the exact same parameters apply. If I have y is 1 over x plus d, if d is positive, it'll be a vertical shift up. If d is negative, it'll be a vertical shift down. When this happens, the horizontal asymptote becomes the horizontal asymptote. So your horizontal asymptote becomes y equals d. When you shift left or right, you have y is equal to 1 over x minus c. If c is positive, it's a shift to the right. If c is negative, it's a shift to the left. Now what happens to your vertical asymptote? Vertical asymptote is wherever your denominator is 0. So x minus c is 0, or x is equal to c. You're going to have vertical compressions and stretches when you multiply by a constant. And if a is positive, this is a vertical stretch. When the magnitude of when a is greater than 1, it's a vertical stretch. When a is between 0 and 1, it's a compression. And of course, when a is negative, it reflects it across the x-axis. So it'll go like this when it's negative. Now, when y is 1 over bx, when b is greater than 1, it's a horizontal compression. Now remember, these two are tightly bound. When the magnitude of b is between 0 and 1, it's a horizontal stretch. And when b is negative, it's a reflection across the x-axis. It's across the y-axis. So it would become very much like this. Now if I wanted to graph y is equal to 8 over x, I will have the same vertical and horizontal asymptotes, but I'm going to have a vertical stretch, factor 8. The domain is going to be the set of x such that x does not equal 0, and the range will be the set of y such that y does not equal 0. Once you have your vertical and horizontal asymptotes in, pick a point. Again, I like 1. When x is 1 and negative 1, when x is 1, y is 8 over 1, or 8. When x is negative 1, y is negative 8. So when you graph your points, it's going to approach the vertical asymptote and the horizontal asymptote. But you see it's always above this function right here, which is the reciprocal function. When you graph negative 1, negative 8, that's down here, And again, it approaches the vertical and horizontal asymptotes. When you graph something like y is equal to 1 over x minus 1, you need to shift your vertical asymptote. Your vertical asymptote will be when x minus 1 is 0 or when x is 1. So go ahead and graph that in. Your horizontal asymptote is still going to be y is 0. And once again, pick a point. Now you want to pick a point on either side of your asymptote there. So I can actually pick 0. 0 is a good one in this case because when x is 0, y is 1 over 0 minus 1 or negative 1. So I can graph 0, negative 1. And it's going to approach my asymptote vertically and horizontally. Let me pick, you can pick any point you want. Let me pick x equal to 2. So y will be 1 over 2 minus 1, or 1 over 1, or 1. So when I graph the point 2, 1, I can sketch so that it goes up toward the vertical asymptote and back down toward the horizontal asymptote. Now I really like this problem because it seems like we're working backwards. If I give you a graph and I tell you it's a translation of the function y is equal to 2 over x, can I find the equation? Well, sure. I just need to analyze where my asymptotes are. I have a horizontal asymptote. Let's see if this is 8. This is 2, 4, 6, 8. So I have a horizontal asymptote of y is equal to 4. And it's positive. So I know my equation will be 2 over x. And in this case, it'll be plus 4, because this right here is my horizontal asymptote. I have a vertical asymptote at, what is this? 2, 4, at negative 3. So this tells me my equation is 2 divided by x plus 3 plus 4. Or answer choice A.